I would like to introduce Jonathan Stray. And a moment, forgot my notes. So Jonathan leads the Overview project, which you'll hear much more about in a moment, for the Associated Press. This is a Night News Challenge funded project, or at least it started that way. And it's a visualization system to help investigative journalists make sense of very large document sets. You'll, again, hear much more about this, and this is why we invited Jonathan here today to tell you about these really exciting developments in what is called data journalism. He also teaches computational journalism at Columbia University, and he was formerly an interactive editor for the Associated Press and a freelance reporter in Hong Kong. And prior to that, he was a senior computer scientist with Adobe Systems. So you might be wondering about this man's background. He actually has a master's degree in computer science and a master's degree in journalism. And he has reported for the New York Times, Foreign Policy, Wired, China Daily, and he's really bringing a rich combination of skills and expertise to this question of how to look through these massive data sets and extract some interesting and maybe unexpected results. Jonathan.
Thank you. Well, first of all, thanks for inviting me. I like scientists. I don't normally do science, but it's fun to hang out with them. And at first, I was wondering, why am I here talking at an oceanography institute? But I'm here, I guess, to talk about a change in one aspect of what it means to be a journalist. And I think it's safe to say there are two cultures that are starting to have to learn to work together in journalism. And this is actually, I stole this from a data journalism conference 2 years ago. The words versus the nerds. Traditionally, people went into journalism because they wanted to be writers. They were frustrated novelists, or they wanted to get paid to write. And getting paid to write is a wonderful thing. I have been at various times made my living as a writer. I used to write fiction as well. But journalism isn't writing. Journalism is reporting, trying to figure out what's true, and then communicating. For me, the writing is a vehicle. It's a means to an end. For example, also you could have other types of stories. You could have video stories. You could have interactive stories that I worked on at the Associated Press. Meanwhile, there's this nerd culture, and people with backgrounds from computer science or physics or statistics or these sorts of things. And that's becoming increasingly important. And I'm going to try to show you why and what it's used for in journalism. And it's journalists. It's almost a running joke that journalists are bad with numbers. It's like we can't deal with this fingers. We're word people. Ha ha ha. I don't think it's funny anymore. And I'm going to try to show you why. Data journalism. I am a data journalist. It's a relatively new name for a sort of niche specialty in journalism. Niche, but growing for sure. And I'm going to try to explain why that's interesting. Here's some data. This is data from the United Nations. This is from the Human Development Index. The UN more or less feels that their job is done when they produce this sheet of numbers. There's an enormous amount of work that goes into it. This is surveys across hundreds of countries, all kinds of very complicated metrics and calculations, and they do a great job of this. This is not journalism. It's not journalism because it doesn't communicate to an audience who doesn't already know it. This is journalism. This is thousands and thousands of unemployment numbers. I've seen the original data for this. It comes from the Bureau of Labor Statistics. And let's cut off a little bit projector, but normally if you do a normal text story, what you're going to get is this top line number. Unemployment rate is now 8.6%. This actually only goes to the end of 2009 or something. It's old data. But there's a lot more that's hidden in there. You have unemployment rate first of all, over time, for every month going back many years, you have an unemployment rate for all these different demographics. So the first thing I can do is I can say, well, okay, you know, white women 25 to 44 with a high school degree. All right, so that's 7.1%. I can look for any demographic. And in fact, I can just scroll through here, and all of these different lines tell a different story. And so this top line, you know, everybody unemployment rate, doesn't really give the full picture.
What is the x-axis on this? I don't see what the picture is.
Sorry, it got cut off, but it's time.
Time.
So these are months, actually.
Okay.
Yeah. And so this was, you know, the 2 years immediately following the financial crash. And so you say, well, you know, unemployment went up to 8.6%. That's, you know, not so bad. But, you know, if you're a young white woman without a high school degree, well, then you're looking at 20-odd%. And if you're a young black man without a high school degree, then we're at 48%. So that one top line number actually hides a huge number of other stories. Maybe in my community, it doesn't look so bad. But there are communities in which half of everyone lost their job. So that's not obvious from either that top line number or a chart full of figures. And so that's maybe the first job of data journalists, is to take something like this and turn it into something like this, which communicates the significance of the data and also personalizes it in a way which is relatively new for journalism. Journalism has mostly been about one story, but in this much information, there's usually many stories. Here's another example of data journalism. This is from ProPublica, which does lots of nice work, of data journalism work. Drug companies now have to disclose money that they pay to doctors for speaking engagements, consulting, that sort of thing. What they did is they actually, they have to disclose it, but they don't have to make it easy. So normally what they have is they have a PDF file, a document file, off on some obscure corner of their website, and you have to go through there and you have to cut and paste the numbers, and then you have to, if you want it broken down by state or doctor or drug, you have to do all of that work yourself. And in fact, they did that, and it took them about 6 months. So theoretically, the information is available, it's disclosed. But transparency is a cycle. It's not just about releasing the data, it's about somebody explaining what it means to everyone else. Otherwise, nothing changes. So that's what they did. They took all this information, and now they've summed it by state. So you can see, for example, in Florida, pharmaceutical companies spent $168 million over, so I'm not sure what period this is, to pay doctors to speak, which presumably there's some promotion of the drug in there. Here's another example. This is the Los Angeles Times crime map. This actually is real-time feeds from the police and sheriff department, and you can actually pick any particular neighborhood in LA, and if the gods of the internet are with us today, it will load up. There we go. You can do it. I know you can do it. All right, well, we'll return to that. Fortunately, I have one I've prepared in advance. So it plots the crimes for any particular period of time. You can actually adjust it with a little slider. It's one thing to go to a police website. I don't know how many of you have tried this, and they'll very often have a page where they have the crime blotter. It's another to see it like this. And certain things pop out when you visualize the information that aren't obvious otherwise. For example, although violent crimes, robberies, assaults, homicide, and that sort of thing, grab a disproportionate amount of our attention, actually most crimes are property crimes. In fact, we have a problem of perception in this country. Most people think that crime has been going up in the US. It hasn't. It's been falling for several decades. There are other things you can do. For example, rather than trying to explain extraordinarily complicated policy choices such as a budget, you can build little simulations or models or games that let the audience try for themselves just to understand the problem. So in this one, you're trying to fix the deficit. This is the New York Times again. And you have choices. You can cut foreign aid in half, you can eliminate farm subsidies, and you have to pick some combination of things that balances the budget. I feel that this explains the difficulty in balancing the budget much more effectively than any piece of writing ever could. You can say that there are hard choices that would have to be made. It's a lot different if you have to make the hard choices. So all of these things involve finding data, often that's already available, and interpreting it or making it clear, telling a story with it. News organizations are also doing other things. For example, this is the Guardian World Government Data Index, and a lot of governments in the world are releasing data now, all kinds of data, unemployment data, budget data, environmental data, which we'll of course talk about, political data of various types, election results, that's data. School stores, standardized testing, financial stuff. Of course, financial data is a huge industry on its own. Maps, maps of evacuation zones or flood regions, property values, what people are searching for, social media posts. There's just data everywhere. And some news organizations are not just interpreting it or writing about particular pieces of information. This is actually a search engine for data. So if you want to answer the question, where am I going to get West German, well, I guess it's just German now, but let's say you're interested in a particular part of Germany, right? Where am I going to get German income distribution from, right? I want to know about income inequality in Germany. Well, you can type in income inequality Germany and it will tell you where you can get that data. And that's a fundamentally journalistic service as well, I feel. So, here's the short definition. Data journalism: finding, analyzing, and presenting data in the public interest. Right, so it's got these components, right? You have to do something with the data. You have to, at the very least, say, oh yeah, it's over there. And we as a news organization have checked this out, and we think that's the authoritative source for German income distribution data. Or you have to say what it means. Our analysis of school scores shows that the states that implemented whatever class size policy have improved their grades over the last 5 years. The lecture I gave this morning actually was all about how to analyze data and how to make sure that when you see a pattern like that, it actually means it's a real pattern. It's not caused by something else. And then there's this presentation step. This is a responsibility that journalists working with data have that other people don't. Scientists have to report to their peers. That means they get to use language that isn't necessarily going to communicate to you and I. But a journalist has to communicate to the public. That's a whole other skill. So it's the intersection of these things. Of course, I haven't defined data yet. Most of you probably think of tables of numbers and computers, and yeah, there's a lot of that. But my definition of data is actually a lot broader, and I'll show you why in a second when we get into my work. I'm just going to say it's a collection of similar pieces of information. It's vague. It's intentionally vague. But that's because I tend to do things like think about the books in a library as data. Text is certainly data. We can store it in computers, we can manipulate it. My work involves trying to go through large volumes of text, not even numbers for what I do. So here's an example of some data. It's a card catalog, not many of these left. But conceptually that's what it is, right? This is very well organized data. Here is structured data. This is something called DBpedia. So this is actually data on McGill University. I made this slide for a lecture up there last year. So Wikipedia, of course, and Wikipedia has those little fact boxes on the sides that says, Germany, population this, national anthem, flag, largest city, right? you pull out all of that information. In this case, it's pull out all the little facts from the McGill University Wikipedia page. Now you have DBpedia, which is a structured form that computers can read. That's data too. Not just how many people are there, but the name of the head of the organization and the motto, which I'm going to mangle the Latin. And Marty the Martlet is the mascot. That's stored on a computer somewhere, and in fact, if you want, you can make a table of the mascot for every university that's listed in Wikipedia, which is most of them in the world. This is structured data, right? Normally people think of tables, the relationships between things. Of course, last week we learned that the National Security Agency is recording all calls made by everybody in the US. Why do they do that? Well, they're interested in the relationships between people. That's structured data as well. Or even, this is a piece of an Argentinian court ruling, and we've highlighted the places and the, ooh, I got a laser pointer, I love this, there we go. The places, the names, and the dates. That's structured information as well. There's also unstructured information. This is a page from a notebook in Guatemala. It was recently discovered, this archive. By archive, what I really mean is a room full of falling apart boxes filled with notebooks of what the military government was up to in the 60s and 70s. This was the military secret police. And as, for some reason, secret police always keep incredibly detailed records. And so now we have them. You know, think of the Stasi files, right? So we have all of this. It's literally millions of pages of this, and there's a project at the University of Texas to analyze this stuff. That's data analysis as well. And that's, there you go. That's not that archive, but that's another archive. This is data. This is not well-organized data, but you figure somewhere in there, right, how many people's desk looks like that, right? Somewhere in there, there's a story, if you're a journalist. And this happens all the time. I'm going to show you a story that I worked on. Oh, apparently I'm going to show you later. Let's do it now. No, so we'll just skip ahead. Wait, is it even here? Oh no, I don't have those slides. Okay, so I'm going to show you on the web then. I did some work analyzing documents that were obtained from the US State Department, and they look like this. But there's thousands of pages of this. These are reports of every time a security contractor fired a weapon while protecting a diplomatic convoy or doing something in Iraq. You may have heard the name Blackwater, one of these private security companies. There was a lot of concern during the Iraq War about what these people were up to, because they're not subject to American law, or they're not subject to military law because they're not military. They're not subject to Iraqi law because they're not Iraqis. And so it wasn't clear that there was any accountability for anything these guys did. And so there was a Freedom of Information request filed by a reporter named John Cook, who's now at Gawker. And he got down 5,000 pages of this stuff. And it came on paper, and it looks like this. It just sort of goes on and on and on. And then it goes on some more. And then it goes on some more. I'm not sure if you have a visceral sense of how much 5,000 pages is. Okay, 5,000 pages, if you print it, which I actually did by accident. I thought I was printing 10 pages, this one, but I messed up, and you know, one of my colleagues comes by and is walking with this stack of paper and is like, "Jonathan, did you want to print this?" And I was like, "Yeah, oh, no." So 5,000 pages is this, right? And here's the thing, 5,000 pages is not a lot by modern journalism standards. Let's talk about the WikiLeaks material, the diplomatic cables. Certainly one of the biggest stories in recent years. That was 250,000 documents. You don't print 250,000 documents. You don't read 250,000 documents. You can't. So you need computers to help you work through this. And what I've been working on is a system to help journalists go through enormous quantities of material like this. The story, I'll show you the system in a second, but let me show you the story first. The story that came out of this was, no, that's behind the scenes, here's a story. I got to write this story. These documents show that mostly these contractors fired at approaching civilian vehicles to protect U.S. motorcades from the threat of suicide bombers. Now think about that statement for a second. You've probably heard of a few high-profile incidents at the end of 2007. Blackwater contractors killed 14 civilians in Nisour Square. Headlines, justifiably so, right? What are these unaccountable contractors doing, killing 14 people? But that doesn't answer the question of what they did the rest of the time. To answer the question of what they do mostly, in principle, you need to read every document. Because you're looking for a pattern, you're looking for an overall trend, you're looking for the big picture here. But you can't read every document. So what do? Well, this is the system that I've been working on. I'm going to close this window because I keep going to it and it's so annoying. You're good. Die. Okay, there we go. You've heard this thing, overview, mentioned a few times. Overview is the name of the system that I work on, and what it is a system for journalists to deal with very large numbers of documents. Here I have, in fact this is not even a particularly large example, but it's an interesting example. This is 600 odd documents from, I apologize, it's very small on this screen, from the White House Mineral Management Service, which is responsible for mining and in particular oil wells. This is all the correspondence concerning the Gulf of Mexico before the BP oil spill, as obtained under Freedom of Information law by the Washington Post, I think, filed this request originally. The journalistic question is, did the White House know that drilling in the Gulf, deep water drilling, was unsafe before the BP accident? And so you just go on, it's like emails, it's incredibly boring. Gentlemen, the revenue estimates Mineral Management Service has available for the areas that were under the previous moratoria, blah, 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 blah. It just sort of goes on like this, and you can go through this stuff for quite some time. What Overview does is it automatically sorts the documents into categories for you. So this is all of the documents, all 600 odd. Then it splits them based on the words in them. So you can see this one, and you can't read that. It says the top words are letter, Sherry, which is Sherry Hunter, is one of the employees there, gas, oil, royalty, leases. If you go down even, if you zoom in on that a little bit, this one, the top words in are royalty, RIK, which means royalty in kind, which means oil companies pay their extraction royalties in oil and not money. Royalty relief. What it's done is it's found all of the documents relating to the payment of royalties for leases, and it's put them in one place. So now if I'm interested in those, I can say, oh, well, those are all the royalty documents. Now I've worked that out. And another thing that I found here is there was this point where I think 66 different representatives in the House wrote a letter to President Obama urging that the OCF is offshore continental shelf, I think, be left open for oil and gas exploration. So 60 odd people wrote to Obama a form letter. Obama wrote a form letter back. And in fact, if you look in this folder, what it's found is it's sorted all these documents together, and they're all the same. There's the actual content of the form letter. Thank you for your letter dated February 3, 2009 to President Obama, blah, blah, blah. But we've got 60 odd copies of it. If you get a stack of documents, those 60 odd copies are going to be in there somewhere randomly, and you're going to sort through them, and you're going to come across it multiple times. What this system does is it's put them all in one place. So if you discover that you don't want to read the 60-odd documents, well, I've just tagged them, okay, that's the Obama letter, and now I'm done. I don't have to read anything else in this folder. And so going on like this, it's sort of found all of the different categories of thing. And one of the things that I found is this thing, which I've tagged Atlantis. Atlantis is the name of an offshore drilling platform. And what happened is a group of citizens, somewhere it actually says the name of the organization. It was an environmental organization. There you go. The Mineral Management Service received a copy letter from a special interest group requesting an investigation into BP's Atlantis platform. So actually, there's all this correspondence, 16 documents, talking about these people who had safety concerns, and they were trying to get the original plans. So someone else had expressed concerns, but not about the Deepwater Horizon, about this other platform called the Atlantis. And it's helpfully put all of this together. So within an hour or two, even if you have tens of thousands or even hundreds of thousands of documents, you can't read 100,000 documents, but you can figure out sort of the table of contents. And when you have that much material, the game is about focusing your investigation. What do I need to pay attention to, and everything else you can ignore? Because you can only read, what, a few hundred pages on deadline? Anyway, that's the work I do at Columbia, or at the Associated Press. Now I want to talk a little bit about environmental data, since we're here at the Metcalf Institute. There's a lot of it. Here's an obvious one. Annual temperature anomaly, right? This is the temperature of the planet. We all talk about this one. There's a lot, this has almost been done to death. And yet, journalism still has a role here. And even in this issue, which everybody's talking about, in this case, it's not so much about visualizing the data. It's about, okay, why is this happening? And, well, the scientific answer is, well, it's human-caused, right? But what about that? How does it work? Where did this data come from? Why should I believe this is true? And where did this data come from? Now it's from a lot of sources. It's from temperature weather stations all over the world. It's from fossil records. There's all kinds of things. But in this case, the journalist's role is just explaining what that data means. It's obvious that it's going up, but why? And how do we know? Here's a type of environmental data that I think even environmentalists and environmental scientists don't think about very much. Land use data. This is land use data from Hong Kong. Now, every city has a database of land use records. I guarantee it. The difference is those are starting to be publicly available in digital form, which means, although it was always possible to go down to City Hall and get the records for what's going to be built on that empty lot that was for sale, now, first of all, you don't have to go down to City Hall. Second, you can get all of them at the same time. So this is actually an interactive map of every plot of land in Hong Kong and what's there or what's going to be there. And of course, this is, if you care at all about cities, this is fabulously interesting stuff, right? This is everything from how much parkland are we going to lose in the next 5 years to does one developer have a monopoly on all the housing to are we building in places that are going to be affected by rising sea levels to are they going to put up a building to block my view? Right? So this is both deeply personal and important in a societal level. Radiation data. This is a map of radiation levels around near Fukushima. This data again was online. It wasn't a secret. The Japanese government posted these figures every day for several months. But radiation levels posted on a website in Japanese aren't necessarily, that's not journalism, right? The journalist has an interpretive task here. So the first thing is to plot it on a map, because it was just a chart of place names and figures when you get it, right? So there's this visualization step. But even that's not enough, right? So like, is purple dangerous? What happens if I go visit a purple place? So this is comes to one of the fundamental rules of data. It does not speak for itself. Data is not, without context, we don't know what it means. We have no idea if it matters to us. We have no idea if it's important. If I should care. If, you know, will it affect me? Will it affect my children? Will it affect my livelihood? This is the role of the data journalist as well, to not only show the patterns of data and collect it and analyze it, but to say why it matters. And in this case, actually, any XKCD fans in the audience? Yeah, we got a few. Okay, so XKCD made this chart. It's not XKCD is a web comic. It's not even a news organization, but they did something that actually many news organizations did. They just did a brilliant job of it, which they said, okay, well, 110 nanosieverts per hour, what is that? Well, a chest X-ray is 20 microsieverts, which is, what is that, 20,000 times higher than that. So we're talking, if you stay in one of those purple areas for an hour, that's actually much less than a chest X-ray. But then in these areas, we're starting to get into things that are appreciable doses. And so it compared the data from that accident to things we do all the time. There you go. Extra dose to Tokyo in weeks following Fukushima accident. It's 40 millisieverts versus chest X-ray, a little less. Head CT scan. Look at that. That's radiation from living in Tokyo. That's radiation from a single CT scan. And this is background radiation. This is what you get just by living, basically. It just comes from space. So that gives you an idea of how dangerous the radiation was, which it wasn't unless you were very close to the accident or you stayed there for a long time. The other chart that people did was it compared these doses to cancer rates. So at what doses do you start to see an increase in various types of cancer or various other damages? The same data can be presented in multiple ways, and you have to make editorial choices as a journalist. These are, I think this is brain and neurological cancers in all of the different counties in New York State. This is one way to show the data. It's kind of interesting. You can see Hamilton County has a much higher than average number of cases, and you can start maybe asking why. Is that chance? Is that pollution? Is that a difference in medical care? Or you can show the same data on a map. And now you can start to ask questions like, is this a cluster? Is there an oil refinery right there or something? Such things have happened. It's the same information, just shown a different way. And if you show the same information a different way, you might learn different things. So that's part of the job of the data journalist as well, is to take that same information, which, remember, starts as a table of numbers and does not speak for itself, and find a way to make it say something. And hopefully to say something that's true, which is, again, you have to take great care that you're not saying, oh my God, there's something in the water along the sea that is making brain cancers higher here. Well, I mean, that could be true, but you have to go through some work to see if it is true or not. But it may suggest different interpretations. Remember, this game is all about interpretations of the data, right? It's nice that you have some numbers. What do they mean? And really what we want is we want stories from our data. When we look at all these figures and we do all these fancy visualizations, and I've done it a dozen times in this talk, we're often looking for almost the single sentence summary. So here's some stories from data. Humans are changing the climate. Countries with more guns have more gun violence. Actually, that's not true. We were just looking at that data this morning, but it's plausible. You want to try to take all this information and distill it down. You can think of distilling it down to a headline. And while it's true that life is complicated and you're not going to be able to fit everything that's important in one sentence, if I can't explain to you why you should care about all of this, tables of numbers and pages of documents and all of the stuff that I've been going to, if I can't tell that to you in some way in 10 seconds, I have failed to communicate. I have not done my job as a journalist. Now, what I'm hoping is that you'll be like, wow, land sold to developers to build public housing sits vacant for years? Well, that's weird, and that doesn't seem right. I'm going to read the rest of the article, right? I'm hoping to draw you in, to engage you, maybe with, this, an interesting picture, or something that, really catches your attention. Like, that's one of the things I like about the New York Times piece, is the jobless rate for people like you. Well, I'm white, male, 25 to 44, college graduate. Unemployment rate, 3.9%. Well, man, my demographic's doing great. But of course I can see that it's really the bottom end of the scale. And the picture I get of the world and the economy from all of my educated white male friends is not going to be a very representative picture. Right? So I need to come up with the short story of what's happening. Maybe the short version of this is, the effect of the recession on you might be a lot different from the effect of the recession on someone else. So we're looking for stories. And we're looking for true stories. This is a slide I also used in my other talk. How many of you have heard of correlation is not equal to causation? All right? So here you go. Is global warming a hoax propagated by scientists? There's the NSF budget, and there's the global temperature. So clearly, right? Oh, this one's my favorite. Would M. Night Shyamalan start making good movies again if people bought more newspapers? Well, newspaper sales are going down, and his movies are sucking. So, all right. So it's not just about finding patterns. It's about finding true patterns and causal patterns. This is another slide I stole from this morning. If you see a pattern, there's basically only a few ways that pattern could have happened, and you have to figure out which one, right? Is increasing budget for the National Science Foundation causing global warming, or is it chance? Does more guns lead to higher homicide rates, or is it actually that in dangerous places where there are higher homicide rates, people buy more guns because they don't feel safe? So we're not only looking for stories, we're looking for true stories, and that's part of the craft of this analysis. And these are all techniques from science, right? This leads very naturally into standard science and statistics and that sort of thing. And that's what the nerds are having to bring into journalism. It's not, it's exciting that it's actually now very easy to make a map like this one. You can make this map starting from the spreadsheet in about 10 minutes now with free tools. But making a map is not the same as knowing whether you found a story that's true or not. So that's part of why we're having to bring these techniques into journalism. The other interesting thing about data analysis is we're used to a story being one story, but you can now put whole databases online. So for example, that the pharmaceutical company spending on dollars, you can type in the name of your doctor and see how much money they've taken from which drug companies. That's new. That's something different. That's a very different model than the sort of one-size-fits-all model of journalism. And there's that map again. Journalism is also, I'm now starting to push the frontiers of what you can do with data in journalism. You can start to ask questions about what happens after the story is published, which is something you could never do before. This is a picture of Google News. All of the news in the world is now being aggregated into one place and sorted. You can now get stories from everywhere, not just one place from one site, or from social networks, or from customized news readers. There are all of these systems now that are filters for what we can read. And some of you have probably heard of the idea of a filter bubble. No? Okay, so that's the idea that if Google is personalizing what I see based on what it thinks I'm interested in, that sounds really valuable, and it is, right? I don't get things that I don't care about. Maybe that's narrowing my horizons. And so part of what I teach in my class in Columbia is first of all, the technology, how do you build this, but also the sociology and the ethics of these types of systems. I don't want to build a new system that only tells me things that I already agree with. It should show me things that I disagree with. And in fact, from data, we can see politics. This is a map of sales of political books just before the 2008 election. So when you go to Amazon, it says, if you bought this, people also bought that, right? You can follow those arrows, and what you find is that people buy the red books or the blue books, but not both. You can see this in all sorts of ways. It's visible in the network of who people tweet at. If you collect in bulk all of the tweets about political subjects, you find that people generally talk to their friends who have a similar opinion. And this is not something that the internet created. This is normal. This is homophily. Homophily means liking the same. This is pretty much the oldest rule of social science, is that people will organize together in groups of people who are like them. Like look around the room here, right? We're in a group of almost entirely white, I would venture to say well-educated people, right? We're a certain demographic. The world doesn't look like us, and yet we're all here in the same room rather than being randomly spread out. This is normal. This happens everywhere, and you can now see it in the data. This is an analysis of Persian language web pages. So Iranian web pages, and they're near each other if, in this diagram, if they have a lot of links between each other, like when you click one link and go to another page. And what you find is that all of the expat community has a lot of overlap with the reformist politics community, which is separate from the conservative politics and the religious community. So we can actually paint pictures of how we're associating with each other from the data. And this raises questions about how is our worldview shaped and who should we associate with? We have the ability to talk to anybody in any country at any point. We have these global networks. We can do it essentially for free, but that doesn't mean we do. So we have to distinguish between the possibility and the actuality, the infrastructure and the communication flows. And we're starting to be able to map these things. And we can even see information spread throughout the web. So this is, again, through the 2008 election. What they did is they tracked quotes. So our entire economy is in danger, which I don't remember who said that, but you can put lipstick on a pig, which was a Sarah Palin quote. And they actually watched it spread through this mass analysis through all of these different sites. You can see there's a peak of interest and then it fell off over the years. We can actually see information flow now. What I've been trying to organize is a project to use machine translation, so automatic computer translation, to watch information flow between cultures. I want to answer questions like, what types of news stories, when they are printed in the Chinese media, make it to the American media? Because that's going to answer questions about what don't we know. Most of what we know about other places we get through the media, so that's a lens, that's a point of view, it's a filter, it's a perspective. And right now, we're just in the beginning stages of being able to say, what type of perspective is it? Here's another example. Remember the Coney 2012 thing, Invisible Children? Yeah. This is a map of how that spread through social networks. And this is Jason Russell, who was the director of it. And sort of, you can see it spread through his friends, but then there's these other groups, right? People are always organizing communities, and it turns out that actually this is Christian youth in the Midwest, because they had been going from school to school showing this video beforehand, or not that video, but another video, and talking about that. So we can actually track the spread of information flow now. So there's a few places that journalism needs computer science. I've jumped from data to computer science here because I'm a computer scientist and that's what I work at. Columbia has a new joint master's degree in journalism and computer science, which is the program that I teach at. And it's not just I said data journalist's job is to find, analyze, and present data. But when we start asking questions about what happens after the story is published, we have to look broader. And so a lot of my work is about applying computer science techniques to ask about what happens after it's published. What are the systems that control what stories we actually encounter? Because there are millions, I mean literally millions, of news stories each day all around the world. How many do you read? 10? 20 if you're a news junkie? Right? So some tiny fraction actually makes it to our attention. There are lots and lots of computers involved in what tiny fraction makes it. You know, aggregators, social networks, search engines. And so we need to be asking questions about what is the interaction between the algorithms and the sociological effects. So that's the filtering. And then tracking. How does information flow? Who's represented, who's not? What do we learn about, what do we not learn about? We have this idea that maybe some people are more influential than others. Can we see that now? This is a remarkably interdisciplinary field. In the center there are the key topics, the sort of major units of the course that I teach at Columbia, which is called computational journalism. And then around the edges are the disciplines that we draw from to do this. And it's everything from classic sociology to artificial intelligence. It's really cross-disciplinary. And when you start to ask questions like, how does the Google News story ranking algorithm change how Americans perceive China? You're asking a question which is at the intersection of all of this computational stuff and all of this social stuff at the same time. And so there is something between the words people and the nerds people that is extraordinarily rich and I think increasingly important to ask these types of questions. Because we live in a world where there is so much data, we need to understand what that means. And that, I think, is the role of the data journalist. Thanks.